There's been a lot of talk about how fast robotics is moving, but what just happened in China caught everyone off guard. During a massive national event, robots didn't just show up, they completely stole the show. These aren't the clunky machines we've gotten used to seeing in labs or factories. They're showing up in entertainment, sports, homes, and places we never expected. Some of them are even starting to take on jobs people do every day. It's impressive, and it's a little bit unsettling too. China's Lunar New Year Gala is one of the biggest TV events in the world. It's broadcast nationwide and draws hundreds of millions of viewers every year. Most people tune in for the music, dancing, and traditional performances. This time, something unexpected happened. A group of robots walked onto the stage and joined the celebration. The robots were called H1, built by a company named Unitary Robotics. 16 of them took part in the show. They were dressed in red and white vests and moved with a level of coordination that seemed almost unreal. They weren't following someone with a remote or being puppeted behind the scenes. They were fully autonomous. Each one was running off artificial intelligence systems that helped it understand where it was, what the beat of the music was, and how to respond with the right movements. The performance relied on infrastructure built by Alibaba's AI division. Their system processed spatial positioning data in real time. This allowed the robots to stay in sync with the performers around them, reacting almost instantly to the music and stage conditions. The fact that they danced to a traditional Chinese folk routine made the moment even more striking. It was high-tech machinery taking part in something deeply cultural. The dance wasn't the only thing they were capable of. During the same broadcast, the robots demonstrated that they could walk, run, and jump. All of this was done in a controlled performance space, but the mechanics were real. Each movement came from a combination of high-speed processing and physical design built for balance and agility. H1 stands roughly 180 centimeters tall and weighs about 47 kilograms. It's not oversized or bulky, which makes it more believable when you see it move like a person. The entire show marked the first time a large group of humanoid robots performed together on a national stage without any manual control. It wasn't just a tech demo. It was a reminder that robotics is moving into public spaces in ways that feel closer to everyday life. After performing in front of millions during the Lunar New Year Gala, the H1 robots went back to doing something far less glamorous but just as important. They're now being used in actual factory settings, especially in the automotive industry. One of the early adopters is Geely, a major Chinese automaker that also owns Volvo and holds stakes in several international brands. They've started using H1 robots at their production facilities. The H1 robot isn't just built for performance on stage. It's designed for work that requires steady movement, physical coordination, and real-time adaptability. It stands about 180 centimeters tall, weighs 47 kilograms, and can reach running speeds of up to 5 meters per second. For a humanoid robot, that's quick. It can also carry up to 30 kilograms, which is useful in environments where lifting and relocating parts is part of the daily routine. At Geely's facility, H1 robots are being used to assist in assembling automotive components. These tasks require a lot of precision, especially when dealing with mechanical parts that need to fit exactly into place. The robots are good at handling repetitive or physically demanding steps in the process, which reduces the strain on human workers. It also cuts down on the risk of injury in areas where heavy lifting or exposure to sharp tools is involved. While the robots are reliable and efficient, they're not replacing people entirely. Factory work often involves troubleshooting, adjustments, and complex problem solving. That still falls on the workers. H1 helps by handling the more routine and repetitive tasks, so human employees can focus on the things that require judgment or hands-on experience. Chinese companies have been talking about scaling up the use of humanoid robots in industrial settings, and H1 is part of that shift. By introducing robots that can walk freely, carry loads, and adapt to human-designed workspaces, manufacturers are aiming to create smoother workflows without overhauling their entire production lines. It's not just about automation. It's about fitting robotics into the current structure in a way that makes sense. As of now, H1 is being positioned as a collaborative tool. It doesn't stand apart from the workforce. It's meant to work alongside people, handle the heavy or repetitive parts, and free up time for other tasks. That's where it's proving its value. Not by taking over, but by stepping in where it makes things safer or more efficient. Not all humanoid robots in China are headed to the factory. Some, like G1, are being developed with a completely different goal in mind: sports. Built by Unitary Robotics, the same company behind the H1 robot, G1 has become known for its soccer skills. Over the past year, it's been steadily improving, and the demonstrations are starting to turn heads. G1 is smaller than its factory-focused counterpart. It stands around 130 centimeters tall and weighs about 35 kilograms. The design gives it agility and balance, which helps when it's doing things like running, changing direction quickly, or even kicking a moving ball. It's been clocked at speeds over 7 kilometers per hour, which is fast enough to keep up in casual games. But it's the movement range that makes it stand out. G1 has 23 degrees of freedom, meaning its joints and limbs can move in ways that allow for flexible, natural-looking motion. This flexibility doesn't stop with sports. The robot's three-fingered hands can perform more delicate tasks, like handling fragile items or preparing food. These aren't just theoretical claims either. In live demonstrations, G1 has shown the ability to grab and manipulate various objects with accuracy. The hardware is paired with software that adjusts grip strength and hand position depending on what the robot is trying to do. The robot is powered by a 9,000 mAh battery, which keeps it running for about 2 hours before needing to recharge. For tasks like soccer training, food prep, or customer interaction, that window is long enough to be useful without creating long delays between sessions. And unlike many high-end humanoid robots from other countries, G1 is relatively affordable. Its starting price is around $16,000, which puts it within reach for some schools, research labs, or even hobbyist developers. While G1 is still in the development stage, the progress it's made shows how fast robotics can evolve when the hardware and software are built to grow together. It's not being pushed as a full replacement for athletes, and there's no plan to put it on a professional team. But the technology behind G1 shows how robots could eventually take part in training drills, simulations, or public demonstrations, especially in settings where consistency and safety matter. Robots like G1 are stepping into new territory. They're not being locked into one purpose. Whether it's kicking a ball or flipping something in a kitchen, they're being built to adapt. And as they continue to improve, it's hard to say where they'll stop. Some robots are designed to work in factories. Others are being built for something a little closer to home. Wanda 2.0 is one of those robots. Created by Unix AI, this humanoid is being developed to take on a wide range of everyday tasks, both at home and in commercial spaces. Instead of focusing on speed or brute strength, Wanda 2.0 stands out for its precision and coordination. In one of its recent demonstrations, the robot threw darts and even handled a bow and arrow. The movements weren't stiff or awkward. They looked smooth and controlled, showing just how finely tuned its hardware is. These tasks aren't just for show. They're a way to prove that the robot's arms, hands, and sensors can handle detailed actions that need both focus and control. Wanda 2.0 comes with dual arms and bionic hands that have 8 degrees of freedom. That means its fingers and wrists move in ways that are similar to how a person's hand would respond when picking something up or adjusting grip. It's also equipped with intelligent grippers that adapt to different types of objects. Whether it's holding a small cup or grabbing something heavier, the robot figures out how much pressure to apply and how to secure its grip without crushing or dropping anything. What makes Wanda 2.0 interesting isn't just the hand movement, it's how well it plans those movements. It uses trajectory planning to figure out the best way to reach for something, grip it, and then follow through with whatever action it needs to take. In practical terms, that means it can do things like serve food, pass an item to someone, or handle tools with accuracy. The potential applications are broad. Restaurants, clinics, offices, and even smart homes are all spaces where a robot like Wanda 2.0 could step in. The idea isn't to create a robotic butler or a full replacement for service workers. It's more about building a system that can support routine tasks that don't require a human's full attention. Over time, these small interactions could help people focus on more pressing work while the robot handles the background jobs. In the middle of all the advanced robotics being used for industry, speed, or sports, one robot stood out for doing something far more subtle. Instead of lifting heavy equipment or showing off technical tricks, this robot picked up a brush and wrote. Its name is Adam, and it was introduced to celebrate the Lunar New Year. Adam wasn't just drawing random lines. It wrote the Chinese character Fu, which is a traditional symbol of good luck. During the holiday, it's common to see this character displayed on red paper and hung in homes and businesses. That's exactly what Adam did, except it wasn't a person holding the brush this time. It was a machine designed to imitate the smooth, practiced movements of human calligraphy. To make this possible, the robot was built with high-precision servo motors. These motors control how the joints move, allowing the robot's arm and hand to follow curves and strokes without jerky motion. But the hardware alone isn't enough. Adam also relies on machine learning and imitation algorithms. It studies how calligraphy is traditionally done and then adjusts its own movements to match that style. Over time, the robot can improve by learning from each attempt. That process is based on reinforcement learning, where the robot receives feedback and uses it to refine its accuracy. It doesn't just memorize patterns. It watches how the strokes are formed and works toward repeating them with more control and balance. What makes this different from a printer or a mechanical writing arm is the motion itself. Adam's joints and actuators are modeled to move more like a real human arm, so it can adjust pressure and motion in a way that reflects the techniques behind the writing. It's not about copying the image. It's about copying the motion that creates the image. This kind of work brings robotics into a new space. It's not solving a logistical problem or boosting efficiency. It's interacting with tradition, using modern tools to take part in a practice that's hundreds of years old. The result isn't perfect, but it's precise enough to show that robotics isn't limited to mechanical labor. In some cases, it can be used to preserve and participate in culture, even in forms that were once considered deeply human. While a lot of robots are being designed to perform specific tasks, there's a growing interest in how they move. That's where Torso comes in. It's a project by Clone Robotics, a US-based company working on something very different from the usual motor and joint setup. Instead of relying on traditional mechanical parts, Torso is built with artificial muscles and hydraulic tendons. This kind of design doesn't just change how the robot looks, it changes how it behaves. The movements aren't rigid or mechanical. They flow more like a person's. That's because the hydraulic tendons mimic the way human muscles stretch and contract. The goal is to make motion smoother and more lifelike without needing to script every step. The name Torso refers to the upper part of the body being developed, which is still in the testing phase. Engineers have been sharing footage of its performance, showing how the robot bends, twists, and shifts weight. There's no full humanoid figure yet, but the core structure is already functioning in ways that suggest potential for real-world use. One of the most promising areas for this kind of robot is healthcare, specifically physical therapy and rehabilitation. A machine built with artificial muscles could help patients relearn how to move after surgery or injury. Instead of simply assisting with lifting or balancing, a robot like Torso could actually teach motion by guiding limbs in ways that feel natural. It could follow a patient's own movement and provide gentle resistance or support based on real-time feedback. This approach also opens possibilities for training simulations or support systems for people with limited mobility. The robot could serve as an extension of the body, helping users regain motion gradually while keeping pressure on joints and muscles in check. Clone Robotics has been focusing on the biomechanics behind each movement, aiming to design machines that respond to physical forces like tension and compression. These are the same forces human muscles deal with, so the closer the robot can get to that model, the more useful and natural it becomes. While a lot of these robots are being developed for industry, therapy, or daily life, there's also growing interest in making robotics more accessible to the public. In Seoul, that effort just took a major step forward. A new museum dedicated entirely to robotics and artificial intelligence has opened its doors, giving people a chance to see up close how far the technology has come. The museum is housed in a building designed by Melike Altanışık Architects, a Turkish architecture studio known for futuristic projects. The structure itself looks like something pulled from a science fiction film. Built with robotic welding techniques and covered in sleek metal panels, the building sets the tone before you even walk inside. Inside the museum, visitors can interact with real robotic systems. It's not just a display behind glass. There are exhibits where people can control robots, test out artificial intelligence features, and observe how machines operate in real-world situations. Some of the robots on display walk on 4 legs, others assist in medical settings, and some are designed to interact directly with humans. The goal of the museum isn't just to show off what's possible, it's to create understanding. By letting people see and use these technologies, the experience becomes more grounded. It's easier to picture how robotics fits into normal life when you're the one pressing the controls or watching a machine navigate a challenge. There's also value in showing how quickly things are moving. Some of the robots at the museum would have seemed impossible just a few years ago. Now they're being used in classrooms, hospitals, and research centers. It's not a distant future. It's already starting to feel familiar. If you're into this kind of tech or just want to keep an eye on what's actually happening, not what might happen someday, stick around. Hit that subscribe button, give this a like if it helped you understand something new, and let us know which robot stood out to you the most. We'll catch you in the next one.